This is very important example. We have to find the basis of the vector space generated by these polynomials. So 4 polynomials are given to us, right? So to get the basis that is generated by these polynomials, we have to first write the coordinate vectors of these polynomials relative to the ordered basis, and then we write all those coordinate vectors in a matrix form, and from there we get the matrix into a row echelon form, and from row echelon form matrix we get our required basis, right? So let V be the vector space generated by the polynomials. The first one is, let's take V1 to be equal to x cube plus 2x square plus 3x plus 5. And then the next polynomial given to us is, let's say V2 to be equal to 2x cube plus 3x square plus 5x plus 8. And then let V3 be equal to 3x cube plus 4x square plus 7x plus 11. And the last one is, let's name this as V4, and that is x cube plus x square plus 2x plus 3. Writing the coordinate vectors of the given polynomial relative to the basis. Yes, what are the bases? Here degree is 3. So writing the bases as x cube, x square, x and then 1. So these are the bases. Now writing the coordinate vector for V1 relative to these bases. So that is equal to just writing the coefficients, that is 1. The coefficient of x cube for V1 is 1. And then writing the coefficient of x square as 2 and writing the coefficient of x as 3 and then is 5 with dash in a column format. Then writing the coordinate vector of V2 relative to these bases. So that is equal to 2, 3, 5, 8 dash. Then V3b, that is equal to 3, 4, 7, 11 dash. And then V4b, that is 1, 1, 2, 3 dash. Let's write all these in a matrix form. So just write straight away as 1, 2, 3, 5 in row, right? So this is 1, 2, 3, 5. You have to write these in a row. Then is 2, 3, 5, 8. Then is 3, 4, 7, 11. And then is 1, 1, 2, 3. Applying the row operations to get the matrix in a row echelon form, I'm already having 1 over here. Required to make this 2, 3, 1 to be as 0. Writing the first row as it is. To make 0 over here, we need to change the row 2 and adding its elements to the row 1, but row 1 should be first multiplied with negative 2. Please keep in mind, always take the advantage of this 1, right? 1 is multiplied with minus 2, we get minus 2, adding this to 2, we get 0. Multiplying 2 with negative 2, we get minus 4, and adding this to 3, we get minus 1. 3 is multiplied with minus 2, we get minus 6, adding this to 5, we get minus 1. 5 is multiplied with minus 2, we get minus 10, adding this to 8, we get minus 2. To get 0 over here, row 3 needs to be changed and adding these elements to the row 1, but row 1 should be first multiplied with negative 3. 1 is multiplied with negative 3, we get minus 3, adding this to 3, we get 0. 2 is multiplied with minus 3, we get minus 6, adding this to 4, we get minus 2. 3 is multiplied with minus 3, we get minus 9, adding this to 7, we get minus 2. 5 is multiplied with minus 3, we get minus 15, adding this to 11, we get minus 4. Now to get 0 over here, row 4 needs to be changed and adding its elements to the row 1, but row 1 should be first multiplied with negative 1. So we get minus 1 plus 1, that is 0. Then minus 2 plus 1, we get minus 1. Then minus 3 plus 2, we get minus 1. Then minus 5 plus 3, we get minus 2. So we have applied 3 operations to get 3 zeros over here, and now this becomes our leading element. To get the leading element of the row 2, we need to make this to be as 1 and other entries to be 0. To get 1 over here, just multiply the row 2 with -1. Simple. So multiplying the elements of the row 2 with -1. Writing the first row as it is. And writing now the elements for the row 2 by multiplying with -1. So we get 0, 1, 1, 2. Right? Writing the remaining rows as it is. To get 0 over here, row 1 needs to be changed, but adding its elements to the row 2, but row 2 should be first multiplied with -2, taking the advantage of this 1. So 0 multiplied with -2, we get 0, and adding this to 1, we get 1, no change. 1 is multiplied with -2, we get -2, adding this to 2, we get 0. 1 is multiplied with -2, we get -2, adding this to 3, we get 1. Multiplying 2 with -2, we get -4, adding this to 5, we get 1. Writing the second row as it is. To get 0 over here, row 3 needs to be changed and adding its elements to the row 2, but row 2 should be first multiplied with 2. Right. 0 multiplied with 2, we get 0, adding this to 0, we get 0. 1 multiplied with 2, we get 2, adding this to -2, we get 0. 1 is multiplied with 2, we get 2, adding this to -2, we get 0. 2 is multiplied with 2, we get 4, adding this to -4, we get 0. To get 0 over here now, row 4 needs to be changed and adding its elements to the row 2, but row 2 should be first multiplied with 1 only. 0 multiplied with 1, we get 0, adding this to 0, we get 0. 1 is multiplied with 1 and adding this to -1, we get 0. 1 is multiplied with 1, adding this to -1, we get 0. 2 is multiplied with 1, we get 2, adding this to -2, we get 0 again. So this is our row echelon form. But this matrix is obtained by using the coordinate vectors, right? So we need to find the basis for the vector space. So getting basis from the first row, this is the coefficient of x cube, this is the coefficient of x square, this is the coefficient of x, and this is the coefficient of x0. The basis from the first row is x cube plus 0 into x square plus 1 into x plus 1. So it becomes x cube plus x plus 1. And basis from the second row, it is 0 into x cube plus 1 into x square plus 1 into x plus 2 into x naught. X naught is 1 only. So it becomes x square plus x plus 2. So these forms the basis for vector space V. Thank you.